Yesterday we looked at an example where we found a bunch of factors. And here's an example that was at the top of page 18 where they had x cubed plus 2x squared minus 13x plus 10. And they found three factors of this. So we've got this equation here that x cubed plus 2x squared minus 13x plus 10 is equal to x minus 1 times x minus 2 times x plus 5. Now, one of the things that I pointed out in last class is that when you multiply x minus 1 times x minus 2 times x plus 5, the first terms, all those x's, they all multiply together to get that x cubed. And the last terms, when you multiply all of your last terms together, the minus 1 times the minus 2 times the plus 5, that gives you your plus 10. Now there's a whole bunch of other things that have to get multiplied, and those will result in the 2x squared and the minus 13x. But a key important thing to notice is sort of the same idea as FOIL. Your first terms multiply to get your first value. Your last terms will multiply to get your last value. And this leads to something called the factor property. The factor property says that if you're looking for a factor, look at that last term. Look at the 10. The only possible nice values for a factor will also have to be a factor of that constant term. So if I was asked to factor this completely, I wouldn't try x minus 7, because 7 isn't a nice factor of 10. I might try x plus 2. I might try x minus 2. I might try x plus 5 or x minus 5, x plus 1 or x minus 1. But I won't try x minus 3, because 3 isn't a nice factor of 10. And so when we get to questions like example 3, which we're going to do right now, which says factor completely and no values are given, to check, we're going to look at that constant term to give us a hint. Yes? Yes. That other one could have had an x minus 10 in it. So in this one, here's my constant value. It's a really nice low number. The only possibilities that are factors of 2 are 1 and 2. Now, it could be positive 1 or negative 1 or positive 2 or negative 2, but there's not that many to check. And I like to start with the 1s because using 1 is really easy to use in the remainder theorem. So maybe we'll just right now, possibilities. Our possibilities are plus or minus 1 or plus or minus 2, which means that our factor possibilities those are the only ones that are nice that could possibly work. And I'll clarify what I mean by nice in a bit, because we're going to get another factor in this one that isn't listed here, but I'll just say that that one's not quite as nice as these ones. Be a little bit factor discriminating, I guess. Okay, so if those are the possibilities, we need to find one that works. Now, options here are the remainder theorem or synthetic division. I like to start with the remainder theorem with the 1s. So I'm going to check, should we try the minus 1 or the plus 1 first? Just pick one at random. Minus 1? So if I plug in minus 1 into my equation, if I'm saying p of negative 1, I'm going to let p of x equal this. I'm going to label that so that I can use this notation. P of negative 1 is going to be 3 times negative 1 cubed minus 4 times negative 1 squared minus 5 times the negative 1 plus 2. So if we multiply this all out, this will be negative 3. This will be negative 4 plus 5 plus 2. So which one is the factor, the x plus 1 or the x minus 1? Right. So x plus 1 is a factor. And what we're going to do, and I'm going to just write out the steps for you at this point right here so we have them. Okay, number one, we're going to use our factor theorem to find one factor. That's what we did. Step one is above. Once we found that one factor, we're going to use that factor and use synthetic division and write the division statement, which I'll just write like this, but the remainder will be 0, so it'll just be our polynomials are equal to our divisor times our quotient. And then finally, you're going to factor the remaining quotient, if it's possible. If it ends up being a quadratic equation, you'll be able to factor it, or possibly factor it. If it ends up being another x cubed, you're going to have to repeat steps 1 and 2 again. So here's our steps. We've used the factor theorem. We've found one factor. We know that x plus 1 is one of our factors. Now we can use synthetic division. If I'm dividing by an x plus 1, a negative 1 would come out in front here. And our original one had 3, negative 4, negative 5, 2. So you bring down your 3, multiply, add, multiply, add, multiply, and you should get this remainder to be 0. What's our division statement? Well, our polynomial that we started with is equal to our quotient, which is x plus 1, and we're left with 3x squared minus 7x plus 2. And because we're left with a quadratic equation, in this case, we don't need to repeat the process. If this was an x cubed, you'd have to repeat process 1 and 2 for your new polynomial that you'd like to factor. But because this is a quadratic, you may be able to factor this one right now. Now, if I could factor this one, because it's a 3x squared, it would have to be 3x and x, because those are my first terms. Is there a way to get the outside and the inside to make a minus 7 and still have your last terms multiply to give you 2? Yes. If you put your 2 out here and your 1 there, my outside would be 6, my inside would be 1. If they both would be negative, I would get the negative 7, and my last term, negative 1 times negative 2, is positive 2. So now we have factored this completely. What's that? Yeah, I was discriminating against this factor. I said this one's not nice. Notice in my list, x plus 1 and x minus 2 were listed at the beginning. Right? Those I listed as possibilities, but I didn't list the 3x minus 1. And the reason I didn't list the 3x minus 1 is because if you wanted to use your factor theorem for that one, you'd have to plug in 1/3, which is a fraction, which is just not as much fun to plug in. And you can't use synthetic division with 3x minus 1. We have to use long division. There is a technique for synthetic division with numbers in front, but we don't learn that. So you can look that up on Google on your own time if you really want to. But we just learn synthetic division when they are nice factors, x plus something or x minus something. The ones for practice. We're going to take some time to do some right now. In this order, do 5, then do 11, then do 9, and finally end with 10b.